Welcome to the new session. Working with this topic is talking about working with Multi-CAD, the power of flexible modeling. The area that I'm going to cover this afternoon is four area. Mainly is talk about modeling in Creo Parametric in multi-CAD environment with multi-body function. So let me show you the first topic first. How do we work in multi-CAD environment? So assuming that we are now working for this part called light body, all right? So this is, I'm using a traditional method. I'm using a traditional method, modeling method in Creo, doing step by step, feature by feature, to form the shape. All right, add chamfer, add shell, etc. Pattern the part, etc. So when you after you complete this, right, this is called working in Creo. So how can I work together with, say, for example, SolidWorks? So I may want to get some information from SolidWorks. So in Creo, right, we can in this is a part mode. Take note, this is a part mode. I can simply go import and open up the SolidWorks part directly from the folder. Directly open or import into the environment. Okay, once you do that, right, your part will be come into the environment like so. Then this is your SolidWorks model. So SolidWorks model is now come into the Creo part as a separate body number 2. So body number 2, right, this is your part from SolidWorks or from other CAD, UG or whatever CAD you have it. So become an import feature like so. Now, then so this is to represent my light cover. So let me rename this body to, for example, light cover. All right, this is from SolidWorks. Then you may want to do some cross section. So cross section is nothing new in Creo. So we can simply quickly do a cross section. For example, I cross sec from this part. So for this tutorial, right, I'm trying to show you one function that you might not aware in Creo cross section view. You can do a traditional cross section like so. Under the option, we got one command called show interference. So once you click on this, right, the interference area will be shown in red like so. So you can use this function to check what is the interference area between SolidWorks part and your Creo model by using this cross-section function. So this is my second topic, dynamic cross-section with interference checking capability. Okay, so next we come into the power of flexible modeling. Now, how can we utilize the flexible modeling function in Creo to handle our design change? Or sometimes we call last minute design change requirement. Last minute. So for example, right, if you notice this part, this is the original part from SolidWorks, and the top surface is flat. So, and when I focus on this part, right, I realize that this part is not moldable. This portion is from an undercut, so cannot be molded. So I may want to use our multi-body function to split the body, to split this imported SolidWorks part into multi-body. So I want to use this surface. I want to split this light cover by using this surface. Then I would like to split the orange color showing the new item. So this item has been split out, become two body. So in order to show you clearly, maybe I would like to assign another color to this new body, right? So this is like this. So now light cover, the original light cover from SolidWorks is now become like this. This become moldable, and I already split to a second body. Now from this example, you may see this body, right, in fact is split into like two parts. So I can do a further split. I can split again the body. now, right, I'm going to use another method of splitting called volume split. So simply select one of the surface from one of the volume here. All right, and you can see the color change, right? So again, this part has been split into another body. So let me change the color so that you can see clearly. So another body has been created. So this body number 3, right, when I isolate it, it become like this. So this part is moldable right now. Now let me don't show the cross section, then you can see the full picture. The whole thing is like this. Okay, so this body number 3, let me rename it. Let's say this is light base, right? This is the base, the bottom part. Then the top part, right? The top part is like this. After I splitting up, and the original the light cover is like this. So here I got 2 body. Of course, finally, right, I'm going to merge these 2 body become one, finally. But now I try not to merge first, try to show you the last minute change. For example, right, if I toggle to the right view, for example, this view, let me zoom in. Okay, so notice that the top surface is flat. So if I want to do some changes, for example, I want to make this surface to be a bit curved. So I would like to create a revolved surface. For example, this is one of the ID, the concept, the design change you want to do to make the top a bit bounce up like so. Is it possible? So as a designer, right, I just simply draw out the shape I want. Dimension change according to the size I want. For example, this is the size. This is the surface size I want. Draw center line quickly. So when I say OK, right, this shape is now revolved as a surface. Now because of the cross section, the surface look half only. Again, I would like to recolor. I would like to recolor, apply a transparent color to this surface so they make a bit transparent. Okay, now from this view, right, you notice that this original surface is flat and the new curve is a bound. So how easy or how can I change my imported item from SolidWorks? No history base, right? This one no feature, no history. How can I change this surface and this surface to this shape? And notice there are a lot of brown is now attached to the pattern, the edges. So this is where the power of flexible modeling is can be used. So now we go to flexible modeling, and we select the surface that we want to change, we want to modify. Then we use the command called substitute. Then we simply select the surface that we just created. Then you will notice that the flat surface now is replaced with the quill. And notice all the round or chamfer attached to the edge, right, will be automatically update accordingly. So the parent and child relationship, right, maintain. So let me hide the surface, so you can see the change. So let me cross section, disable the cross section. You can now see the top surface has been updated to my new design without any complex or complicated step. Now, as a designer, right, plastic, we need a constant thickness. That's why we need a shell, right? So notice after I make this top surface to be a bit bounced out, the thickness change. So I want to make this to be moldable, to be constant thickness for plastic. So what can I do? I just simply use a traditional method. Select the surface, offset the surface, offset down to your required depth. So for this one, right, the plastic depth is 2.3 mm. So I just simply offset down the surface from the top. So I got another surface here. So now go back to the flexible modeling. Select the bottom flat surface. This is the bottom flat surface. Then use the same command, substitute with the offset quick. Notice now it follow the curve, the offset surface. So after I complete the whole thing, right, from this view, you can notice, right, the thickness is now constant. Okay, so then again, I deactivate the cross section. You can see the full picture. So finally, right, I would like to merge these two items into one. So I go to body again. I use Boolean operation merge. I want to merge this SolidWorks with this SolidWorks also, but I already do some modification. Right, merge them together, become one body. Now I got body 4. Right, this is my temporary body. Body 4 is equivalent to the top one. So I say okay. So body 4 no longer body 4 is merged into light cover, the whole thing. As you can see, right, the light cover color is gray and the body 4 is green because, right, in Creo 10, when I do a merge, there is a new command called copy surface appearance. So I can disable to copy the surface appearance together so that it won't copy the surface appearance from body 4 to this body that I want, which is the light cover. Right, so now all the color follow my light cover. So this is the power, one of the area of the power of flexible modeling. Now, many people say that flexible modeling is only applied to the imported feature, no history based feature. Can I apply flexible modeling to a history based? For example, the Creo, the Creo feature created part. Things, if I use Creo, right, using parent and child, using feature, I got a parent and child relationship. I can simply modify the dimension. So why I still need flexible modeling? Now look at this example. When I toggle to a view like so, for example, let's say I want to change the let's say I want to change the height of this the bottom part here. So in parametric, right, I simply go to the feature, double click, call up the dimension. Remember 14.4. I want to make this surface downward a bit, maybe plus another 6 mm. So I double click this, change to 20, right? And I say enter. Now before I enter, right, look at the shape. Look at this shape. Enter. The top shape, right, were destroyed. The top shape will change. See? Will change, right? Because the reference is from the bottom for this example. So the parent and child, right, is driven this feature to be going up. Then the top surface or the shape will be changed accordingly. But this is not what I want. This is not what I want. So I cannot change this feature. I got to do undo, go back to the before change. So what happened? Can I change the bottom feature? So bottom feature is also parametric, right? Also feature based. So can I reduce this depth from 15.7, maybe reduce to 10? Now, when I reduce to 10, right, this surface will go down. Yes, correct. But this surface go down, right? This height 14.4 maintained, so that this shape, right, also destroyed. The shape will follow going down. So this also cannot be. It's not what I want. Now, due to this type of parent and child problem, sometimes parent and child is good, but sometimes it gives me a problem to do a changes also, especially when it comes to a last minute change. My boss want me to quickly make this surface go down by 6 mm, whatever. So how can flexible modeling help you in this area? So let me show you in cross section so they can see the change. Now, when I zoom into this area, go to flexible modeling. I don't care what are the parent and child relationship between this top feature and this bottom feature, or whatever feature in between. I can simply use a window selection to select all those surfaces that I want to change, like so. Then simply move. Then simply drop this dragger to one of the surface, maybe this surface. So now, right, you can drag this, make this surface incremental change by whatever distance you want. For example, 6. So I reduce here down 6 mm. This is exactly what I want without affecting all the children from the top, from the bottom, etc. So I'm very safe. I know I'm changing the right term, the right item. So when I do undo, And to see, this is before and this is after. Before, after. So this is one of the example that I can show you how can flexible modeling help you in even though you are not dealing with imported feature, you are dealing with a history-based part. You can also apply flexible modeling on your design. Okay, so yeah, one more thing before I forget to show you. When I isolate the top part, I notice that here I got no slot for my body to go in. So I can use a Boolean operation. I can use the subtract operation. This is the part I want to reference. Body one is the part. No, select wrongly. So the part to modify is this part, and the modifying part is this part. So this part will subtract from here. I want to keep the body. Once I done this, I said okay. So I just hide the body, so you can see the result for the SolidWorks part. Can see the color. Now this is copy the appearance. Copy the appearance from your reference body. The reference body is this color, is brown color. So after I do a subtract, the color from the color from body number one is now reflected in the result body, so that I know, oh, this cut is come from which body, right? By showing the color appearance. So this is one of the example. How can you utilize this copy surface appearance? Remember, right? Okay, so I think with this, right, we are done with the topic that I would share with you. Oh, one more last thing. Replace imported data intelligently. Now, flexible modeling not only can help you to do all these changes that I show you, or the last minute design change, etc. You can also replace your imported data. For example, right? For example, this data, right, is come from SolidWorks version number 1. So I got look at the pattern, the number of pattern, the pattern 1, 2, 3, 4, 5, 6, about 6 whole. So I can go back to the import feature, do an edit definition, then go to here. You can edit your imported feature. You can go and call another version of SolidWorks. For example, V3. I received another V3 version from SolidWorks. So I can simply replace it without redo all the replace, etc. Right? No need to redo. All these things, right, will be replaced accordingly. See? Okay, it was flat, it was flat. Yes, it's still flat. But when I say okay, but theoretically it wouldn't fail. But it will fail, right? Doesn't matter. It will show me the result. It show me the information why fail or where fail, and I can go and fix it, right? By doing so, right, all my bottom, all the subtract, all the substitute, body merge will be replaced correctly. See, here we go. Now it's still bounce out. When I do a cross section, show a cross section, expand the cross section here. When I do a cross section, right, it still show me a constant thickness, right? All the bottom surface, everything is now replaced accordingly. So this is one of the very powerful area, and many users may not aware. Look at the number of pattern totally changed, right? From one version to another version, and imported feature can be replaced intelligently.